Thank you, Courtney. So it's great to be here. Thank you very much. And now I guess my challenge is how do I squeeze in a 25-minute talk into 5 minutes? But we might see a little bit of a delayed propagation. So you all heard a little bit about the science, the cutting edge science. I'll turn the topics a little bit and talk about some tricks, tips, and lessons learned from practical use, and specifically I'll model how we create personalized news feeds. I'll start by telling you what the newsfeed actually is. Then I'll talk a little bit about how we use machine learning and what are the lessons and tips and tricks. And finally, I'll mention measurement, why it's important, and what type of measurement we do. What is the Facebook newsfeed? Many of you might use Facebook and not even know that probably the core part that you're using is the Facebook newsfeed. This is a collection of stories that are important to you and meaningful. It can include images, video, posts from your friends, and it is constantly updating. Our goal is to deliver content that matters to you the most. And we do that by understanding who are the people that matter to you, what are the groups and pages that you're connected to and you enjoy. And at the same time, newsfeed is just a tool. You're always in control. So we offer a lot of settings that let you stay in control. You can decide who you would like to be friends with, what pages you would like to follow. You can obviously unfollow pages or people. You can hide specific posts. And you can even select what posts you would like to see on top. Let me start with some basic stats. Today, we deliver personalized information to over 1 billion people. In order to do that, we have to show hundreds of billions of posts for each of these people, and all of those have to be personally relevant and important to them. And that requires looking at trillions of different posts and selecting, ranking, and displaying the best and most meaningful content. At the same time, it's important for that content to be available immediately. Let's say a friend posts that they're getting married. You want to know that right away, and you want to be the first person to congratulate them. In order to do that, we need to show you that post in under a second so that you can be the first to congratulate them. In order to select all of these posts, everything gets ranked at the time that you visit the newsfeed. So to deliver a good user experience, we need to do the retrieval and ranking in under 200 milliseconds. So pretty large scale and not very much time to do it. It's important for us to deliver what matters to you. And the best way to do that is to show the most important content at the very top of your newsfeed. The way the user interface works is the first thing you see is what's on top of your newsfeed. People are twice as likely to interact with things on top of the newsfeed than with the second story that we display. And that's true for likes, clicks, comments, for any type of interaction, independent of how the content is ranked. So selecting the best thing and putting it on top is important. At the same time, diversity and ordering really matters. We don't want you to just look at the first thing and leave. We want you to stay and look at all of the stories that are important to you. So we need to order them in a way that's diverse and keeps you engaged. So let me run you quickly at specifically how the newsfeed works. Let's say I wake up in the morning, I come in, and I want to look at Facebook. My sister recently has been doing a lot of photography, and my sister is important connection for me. So what happens is newsfeed has learned that photos from my sister are probably important and they should be shown at the top and ranked high. So the first thing I'll see is a photo from my sister. And then there'll be other stories, posts from friends, videos. All of this gets ranked based on the specific personal relevance to me. So I look at the first story, I see the second story, it's about my friend getting married, so I have to like it. I like that story. I looked at another story, but then I have to run to work, so I leave. Well, traffic wasn't bad, so I managed to get to work by 10 a.m. I have another time to look at you. Well, for around here, getting to work in an hour is not bad traffic. So I look at my newsfeed again. What happens is the stories I've seen get pushed down in my newsfeed. And now all the news stories need to be ranked again. And what are news stories? So news stories is everything that has happened in that hour. In this case, there is a new page post, story 8. However, it also includes all the content that I didn't get to see. So everything, including the stories 4 through 7 that I didn't get to see, need to be ranked again, and they need to be ranked based on the context, based on my interactions, and what's meaningful and important to me. So last time I liked a story from a friend. Now you can see that the story from the friend that I didn't see actually gets scored higher. So this time I have a little bit more time. I look at more stories. I comment at a linked story. So next time I'm going to come in, all the stories that I've seen and I've interacted with get pushed down the feed, and I get to see a new set of stories. Since it's only been 10 minutes, there is very few new stories, so only those stories need to be ranked and shown on top. And similarly, this time I get to see all of those stories. So next time I come, there are only new stories that have occurred since that time get ranked. And new story can include something that's new created, something I haven't seen. It could be a new interaction with a story I've seen. So somebody might have commented on a post I've already seen. So being able to see that comment and the new context about it is a new type of story that we need to rank. And what we found is for people to get engaged, we can't show the same type of stories over and over. So even though I like photos from my sister, if my whole feed was just photos from my sister, I would quickly stop going there and start spending time in other places. So we need to find a good balance of relevant and diverse content. So now, how does machine learning help us do that? You already noticed in my example that we rank based on a relevance score. So how do we compute this relevance score? In order to compute the relevance score, one way to do that is to take the signal that people give us on what is relevant and meaningful to them. And that signal is the interactions that they do with the feed. So we have people like stories, we have people click, comment on stories. So we can use those interactions and we can build machine learning models directly against those interactions and predicting those interactions. So we express clicks, likes as a probability and try to predict the probability of all of these events for each of the stories. At the same time, a click is not necessarily equal to a like. For example, if I spend time making a comment about a post, that is probably more significant than just clicking on it. So we need to assign a different value to each of those events. So the way we can rank and model is we can compute a score that's simply a weighted sum of all of those probabilities. So to give you an example, let's say a coworker makes a post about an earthquake in California. So I'm not in California, so I'm not running for my life, but I'm still interested in what's going on. Is it a serious earthquake or not? So I'm reasonably likely to click and find out more about what's happening. I probably don't necessarily want to like this story too much because it's not a happy, good story. And I'm not, since it's far away, I'm not as likely to comment or do other interactions. So we can compute the different probabilities for each of those actions. We can assign a value, and that lets us compute a final score for this specific story that's personal and relevant to me. For the coworkers in California, their model is going to look very different. Why does the structure work, and what are some useful things of modeling things as probabilities of events and assigning weights to them? So the most important thing here is we can use the machine learning to predict something that's directly measurable. So we can measure clicks, we can measure impressions, and we're using the machine learning. The objective function is well defined for you in this case. The models can be trained on their own data, so we can train a like model just on the like data, a click model just on the click data, which helps us with efficiency and lets us separate the training process for the different models. And this further allows fast iteration. We can have different teams working on the different models, so it allows for parallelizing the development and testing the models independently. It also allows for integration of heterogeneous content. So as you saw, we need to decide how to rank a photo versus how to rank a video versus how to rank a post, and we even have to throw ads in there. So being able to decide the relative importance of those, if we can use direct behavior, that makes it much easier. And it allows us to adjust the value independently. Finally, it just works well in practice. So Facebook is a network. We heard about networks, so this is a different type of network. Why does the network structure of Facebook matter, and how do we use it? So what we found out is that people are most likely to interact and engage and care about content that they find meaningful and that is coming from people that they trust, sources that they trust, so people, pages that they believe are important and meaningful to them. So by understanding who are the people that you're connected to and what are the pages and groups that you like and join, and the interaction on top of that lets us understand which content you're most likely to trust and engage. Some of the top features in our models are who is the author of a specific post, or who commented on a specific post, and what is their relationship to you. So in this example, we have Joe, Susan, and Lee, and we need to decide whether Wei's post should be ranked high or low for each of these people that are Wei's friends. So Joe is just a friend that Wei met at the conference. Susan is actually Joe's wife. We don't know that necessarily, but Lee is just a coworker at work. So what's happened in the past is Joe has been somewhat likely to click on posts from Wei, and Susan has been extremely likely to click on posts from Wei. So similarly, we've seen higher propensity of likes and comments from Susan. So that lets us establish that for Susan, we should rank that post a lot higher. So I mentioned features, and I started talking a little bit about some of the features. So what are some of the other features that we use? So we use features about what the content actually is, who is the author of the content, and how have you interacted with the content in the past. In general, the performance of the system is proportional to the number of features and the amount of data that you're training on. I already talked about the data. So we actually have trillions of examples, so a lot of data. We also have hundreds of thousands of features. So if we were to build the model using all of the data and all of the features, we obviously couldn't deliver that in the 200 milliseconds. So we have a bit of a problem here. So how do we prune the features and how do we prune the data so that we can deliver things quickly to our users? So in order to prune the features, what we do is we actually start by training models on smaller amount of data and selecting the most meaningful features. And one way to do that is you can actually train boosted decision trees and find out which of the features are important out of the 100,000. So we start with the 100,000 features and the maximum number of rows that we can, or data that we can fit into memory, and we iterate each time removing the features that are least important and adding more data. How do we cut the data size? So one way to cut the data size is making sure that we train only on the events that are important for each specific model. So we don't have to use the click data when we're training a like model. The other insight is most of these events are rare, so most of your samples are going to be negative. What works very well is undersampling your negative data. You can actually remove most of the impressions where nobody is interacting with the content and keep either all or oversample your events that you care about. Now that we have the data and models, now that we have the data and the features, how do we build the models? So the models need to be really quick. I mentioned boosted decision trees. Those, unfortunately, don't work really well if you have to be quick and if you have to incorporate new data. What we found is that we can use logistic regression, which is simple, fast, and easy to distribute. But we still want the power of the boosted decision trees. So one trick that we're doing to be able to keep both of these is we're using stacking, where we're using the boosted decision trees as featureizers. So we still build boosted decision tree models, and we use the features and richness of the boosted decision trees, but then we can feed the output of the boosted decision trees as categorical features into a logistic regression model. And that works really well in practice. It allows us to start with hundreds of thousands of features, still get the importance of those features, but also incorporate quick changes and have a twitch response. So we heard about neural nets. Can we incorporate neural nets into this model? We actually can. The beauty of stacking is it doesn't have to be decision trees. You can actually add neural nets, and you can use the neural nets the same way you use the boosted decision trees because they're still expensive. So you can use them as featureizers where you drop the output and you just use the last layer as your categorical feature. And you can also feed in sparse features directly into the logistic regression. So some of the learnings here is since data freshness matters, you want a simple model. But if you want the power of the model, you can use stacking to achieve that and use more complex models as featureizers. And this works very well in practice. And you can also control the size of your data and features by undersampling negative data and by selecting the best features. So unfortunately, all of this learning still needs the right objective function. So how do we measure and how do we define the right objective function? I mentioned that if we are predicting impressions or clicks, you have that information. But how do we know if a click or an impression, like dwell time or a comment, is more important? The best way to do that is we have the implicit signals, but we can also add explicit measurements, and we do that through survey data. So the implicit metrics are limited because people might not interact with some specific types of stories that are still meaningful to them. For example, people might not like a sad story or a world event because they tend to like disproportionately stories from friends or people that they're close to. So we actually get a lot of noise in the implicit signals. And the best way to add explicit signals is by surveying and asking people directly the question what they would like to see and what is meaningful to them. So one way to actually look at this is by asking people to compare two different stories. So we can ask people to look at two stories and which one is better. However, that has some limitations because we don't know, are both of these stories bad, are both of these stories good, or is one good or bad? So what we can do is we can do an in-out survey where we just ask them, do you want this in your feed or not? But that still gives us limited resolution. Finally, we can do a rating survey on a multi-point scale. That tends to work very well in practice. It gives us absolute metrics. However, stories are rated out of context. And as I mentioned, context is very important. So we fix that by putting those same surveys in the context of the feed, and that gives us the information that's personalized for each user because it's in your own feed, and it gives us absolute ratings. So there is basically some good things about relative ratings. They're easier. They give you infinite precision, but there are some good things about absolute ratings as well. There is no intransitivity issues. They give us the specific delta of how better it is. So what do we do? Do we choose relative or do we choose absolute? Well, the best thing to do is actually you use both. And the way you do that is you use the information. So how do you incorporate these absolute ratings into, I'm finishing. So the way you incorporate these absolute ratings is by weighing the events and finding the correct weighting for each event for each person using the scoring. So we don't have enough data to train the models directly on those survey results, but we can find weights for the likes and comments that I described earlier in the talk and calibrate those weights directly based on the survey information and how meaningful results are for each people. So the learnings here is the best way is to use both implicit and explicit judgments, and the nice thing is you can easily combine both of them by building models specifically for the interactions and then using judgments and using collected data to adjust the weights of each of those feedbacks. And that also let us incorporate dwell time in a very useful way into the ranking. However, all of the ML and metrics are only tools, and ultimately the goal of the feed is to connect, inform, and entertain people, and that's what we're trying to do. So, thank you.